Okay, finally rewrite the polar equation r equals sine 2 theta in Cartesian form. So again, we want to change our r and theta into x and y. Remember that sine of 2 theta is equal to 2 sine theta cosine theta. That's one of your identities. So we can rewrite this as r is equal to 2 sine theta cosine theta. Also remember that x is r cosine theta and y is r sine theta. So cosine theta is equal to x over r, and sine theta is equal to y over r. Okay, so we can write it as r is equal to 2 times sine is y over r, cosine is x over r. So we end up with r is equal to 2xy over r squared. Okay, now let's think about this for just a minute. We can multiply both sides by r squared. We end up with r cubed is equal to 2xy. Somehow we've got to get the r out of there and get x's and y's in there. So let's think about what we know. We know that r squared is x squared plus y squared. Okay. So do we also know that if we take the square root of both sides, we find out that r is equal to the square root of x squared plus y squared? Does that make sense? If you take the square root of both sides, we get this, right? Well, isn't r times r squared equal to r cubed? So can I replace the r and the r squared with x squared plus y squared times the square root of x squared plus y squared? Correct? Okay, now stay with me. Square root means having a power of 1/2. So this is x squared plus y squared to the first power, and this is x squared plus y squared to the 1/2 power. Well, whenever you have the same base, don't you add the exponents? So 1 plus 1/2 would be 3/2, right? So x squared plus y squared to the 3/2 power is the same thing as r cubed. So what I'm going to do is replace this over here. Normally you wouldn't want to see something like this in your equation. Normally if you have an x squared plus y squared, it's just that by itself, because that's telling you you have some kind of circular thing going on. So we can raise both sides to the 2/3 power, and we will end up with x squared plus y squared is equal to 2xy to the 2/3 power. We have now written that polar equation into a Cartesian equation. Now this one's not quite so easy to graph, so we're not going to graph this one at this time, but hopefully when we do graph something like this, you can see that the graph of this equation and the graph of this equation look the same, just on different types of grids. One's a polar grid and one's the Cartesian grid.